I just wanted to start off by saying I hope you're all doing well. In this video, we're going to be reviewing triangle flowcharts, which is something that we did a few weeks ago. So first, we need to look at these two triangles and determine whether or not they are congruent, and then we need to create this flowchart showing how we know that they're congruent. So first of all, just by looking at this, we know that the side AC is congruent to CE because they both have a single tick mark. So we're naming those sides by their endpoints. So AC is congruent to CE. We also know that segment BC is congruent to side CD because they both have two tick marks. So again, naming those by their endpoints. So when we're thinking about which congruence theorems to use, we have angle, angle, side, side, angle, side, hypotenuse, leg, side, 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 and angle, side, angle. So right now we're given two pairs of sides that are congruent. And if you notice, these two angles are across from each other, so we call those vertical angles. And we know that vertical angles, we can automatically say that those angles are congruent to one another. So I'm just going to draw in these little marks showing that this angle is congruent to this angle because they are vertical angles. So that's all we need to show that these two triangles are congruent. So now we're just going to fill out our bubbles. So we have AC is congruent to CE since they both have a single tick mark. We know that this angle is congruent to this angle. So we're going to name this angle by three letters. We're going to call it A, C, B. And we always want where the angle is at. This angle is at letter C. We always want that letter to be in the middle when we write our angle. So this symbol stands for angle, and so we're talking about angle ACB. So I'm going to write that. Angle ACB is congruent to angle DCE. That should be a C. And notice in both of these, the angle is at letter C, so that C is in the middle here. And then our last pair of side lengths that are congruent are side BC and CD, since they both have two tick marks. So BC is congruent to CD. And now we can go ahead and name these two triangles. And remember, however you name the first one, you want to follow that pattern for the second one. So I'm going to name it the first one, triangle ABC. And if we follow that same pattern for this triangle, we would name it ECD. So this is the completed flowchart for the first one, and we always want to write which congruence theorem we are using. For this one, we are using side, angle, side, because the angle is in between the two sides here. So if you want to write that on top, side, angle, side, or you can write it below down here, either one works. Just make sure you're putting which congruence theorem you're using somewhere in your flowchart. Now in this one, we are given that angle A is congruent to angle C, and we are given that angle ABD is congruent to angle CBD. Again, since the angle is at B, those B's are going to be in the middle. And if you notice, these two triangles share this common side. So since they share that common side, we can say that that side is congruent in both of the triangles. So we're going to write angle A is congruent to angle C. So these two angles, that was given. And then we also are given that angle ABD. So I'm going to write that in. This is the angle symbol. Angle ABD is congruent to angle CBD. So the angle is at letter B, so notice that B is in the middle of both of those. And then our last bubble is going to be that BD is congruent to DB. So we're basically just saying that that line is congruent to itself, because both of these two triangles share that common side, so we can say that they're congruent. So if I name the first triangle ABD, if I want to name the second triangle in a similar way, we would name it CBD. So triangle ABD is congruent to triangle CBD. And now, for the congruence theorem that we used, we're given an angle, angle, and side in that order. Angle, angle, side. So the congruence theorem that we are using is angle, angle, side. And notice that it's not angle, side, angle, because this side is not in between these two angles. So you want to follow with your pencil exactly the order that you're going in. So angle, angle, side. Angle, angle, side. So that's why we're using angle, angle, side. All right, so this is the finished flowchart for this one. Now doing one more example, we're going to look at these two. So whenever we see that these two triangles are right triangles, something that I always like to think about first is, are these two triangles congruent by the hypotenuse leg, or HL theorem? If you see a right triangle, that doesn't automatically mean you can use HL, but it's a good thing to check first. So in order to use the hypotenuse leg theorem, we need to know that the two triangles have hypotenusi that are congruent to each other. So the hypotenuse is the side that is across from the right angle. So that's this side in this triangle, and here's the right angle over here, and it's this side in that triangle. So since both of the hypotenuse have a single tick mark, that means that they are congruent to one another. So that is checked off. Now, in order to use the HL theorem, we also need to know that we have a pair of legs that are congruent. So in this diagram, we're given that one of the legs, BC, is congruent to a leg on the other triangle, FE, and we know that because they both have double tick marks. So it looks like we can use the hypotenuse leg theorem here because we have right triangles. Remember, we can only use hypotenuse leg if we have right triangles. And we're given that the hypotenusi are congruent and that we have a pair of congruent legs. So I'm going to go ahead and write that out. So the hypotenuse AC, again, we named side lengths by two letters. So AC is congruent to the hypotenusi DF. We also know that leg BC is congruent to EF. And again, that's because they both have the double tick marks. Now in this bubble over here, you can write that angle B is congruent to angle E since they're both right angles, which is necessary to use hypotenuse leg. And in the bottom, we want to name our two triangles in similar ways. So if I name the first one ABC, we want to make sure we're naming that other triangle following the exact same pattern. So DEF. And don't forget to put which congruence theorem you're using, either at the bottom or on top of the bubbles, HL. Remember, we just put this here to show that we know we can use HL because we have right angles, since angle B and angle E are both right angles. All right, so I hope that was helpful. Please reach out to your teacher if you have any further questions.